this episode of FUM0084 machining, we are dealing with the lathe manual feed handle and especially the bearing. I found out it's really sloppy. There is axial play and there is also radial play in that one. And not just a little, it's quite a lot. And now this is a piece of hot rolled steel, 20 millimeters thick and 55. It should become 55 millimeters in every diameter. I will now learn how to mill this piece into a usable item. And then we have these Russian ball bearings, which I will use instead of that bushing system, which is really sloppy. And those are actually, I'm pretty lucky with that one. The axle, the Leadscrew from the other end is 19.95 millimeters thick, and it's quite even. And this is 12 millimeters, the hole in there inside. So it's a little bit sloppy fit for a bearing, but better, a lot better than the original, which has 0.3 millimeter slop. Let me show you. This is the end of the lathe screw. It continues from there and goes all the way down there. Okay. And now what we have here. This part is supposed to be a bearing with this surface here. And now when I put it here, you first of all notice it slides in very easily, and if you can see, it's really sloppy, and there is a lot of play in it. And then we have this part, which is there is a hole which is not in the center, and it's for a tapered key, which goes this way, and then you have the tapered key through there, as you maybe see. And the tapered key is like that one. Okay. Well, what I'm going to replace is this unit. And I have a drawing somewhere. I can show it to you pretty soon. This is the drawing in question. The thing is that I need to place here comes two screws, which attach it to the lathe itself, and then there is a 32 millimeter big hole inside, which is suitable for these. Here is my humble setup. I don't have a vise. Yeah, I have one, but this is not suitable for machining workpiece like this, so I have to do without. So I have these are parallels, which I use as a backside support, and these pieces are from a machinist vise. This thing I bought these from flea market in Frankfurt. And then I have this piece of material which I placed back here, and then I pushed this, and when it was there, I assume it's relatively straight. And this is the first surface I will be grinding, and and then I will be using the ER40 collet. This one goes to here, and that one goes up there. You don't see it, but it goes there. And now I just tighten it with this one. It's in the low gear, so this should be, yes, it's there. And then here we have, it's one of the biggest end mills I have. This should be fully adequate for this. This is high-speed steel mill from Wait a minute. Tolerance quite tight. RB. Serfa is the brand. So let's see now. This goes into here. It's there. Oh. Yeah, it was clean. I cleaned it up before I even put it there. So now this goes in here. And there you go. I like this type of keys because they stay in place when I put some force into them. There is another one which is only half of this one and it only has one notch, and I don't like these. They slip and whatever, but it's there. Now the end mill is in place, and then, well, of course we need to put this. It's a lot of this is an exercise as well. This machine does not have this what is it called, the feed, fast feed. Yes, I believe it's a little bit more. Just have to see that I am not milling the milling table. And then let's see that we have room for all movements, especially here. Not that one, this one. Yes, we do. I believe we have more than enough. That corner. This corner then, yeah. So the speed for this end mill should be, well, the feed quite low. Well, let's turn this machine on. I have now a good switch there backside. Yeah. It's low here. Let's see. This is very silent machine in a low gear, really. So I think we should take something like 170 turns. And then the feed rate will be 17 millimeters per minute. Well, let's try 20 millimeters per minute. And now let's touch. Oh, before I touch, I have to use this. There we touch. And then we take, first rock the table that way. And we take, I'm knowing, zeroing my readout. And now, how much? Half a millimeter. I think that's a very good start. We will see what that is. And now, the feed. Table is locked that way. And, well. Let's see how this does. Let's try it manual first. Yeah, okay. Looks like it should do. There we go. This takes some time to speed up. It's first slow, but then the speed speeds up a little bit. This is an old machine and it has, well, it's curious it is. Well, now it's picking up speed. I assume it's the oil which is a little bit thick at first and then it starts to get looser. Yeah. At least we don't have any chatter. And this is really nice and silent. Half a millimeter, okay. I think it doesn't clean it up yet, but let's see. I do this edge of the camera, so. Now I will do blind milling, 0.1 millimeters in order to get a better surface finish. So let's see how this machine can handle that one. So this knob is the auto feed. Well, it has 3 functions in the bottom. If you push it, it stops. This is temporary, which I don't understand where I could use that one. And then this is stays on. This is the main spindle. And then, well, here's a lever. Let's go that way. And there you go. And now we see how much damage I can do with this one. Pretty soon, either we get a very good surface finish, or we get no. I think it handles it quite nicely. Let's see what surprise is waiting us here. Taking very little of the metal out from there. Definitely something, but very little. And it already looks really good. Okay. Oh, I will come back when this side is ready. Let's see what kind of surface finish we have achieved with this setup. Let's see now. This is the piece of material. Well, it's not shiny, which is not a bad thing at all. Would it be shiny, I would be really surprised, but my opinion about this is that it's hopefully this autofocus is not out of focus. Well, it likes to be out of focus. So yeah, this is the surface finish. I believe it's adequate for this project. Okay, now I will do a little bit vacuuming here. Let's see if I can find my... Okay, and now, well, of course, if I would have been wise, I would have let it stay here and then just mill the other side. Yeah, but I'm not a wise guy. We need to have these 2 parallels here. This goes on top of that. And then how I do this, I have this parallel, which I put into this slot. Well, and then I just push this against the parallel there, like that. It's there. Alright. Let's take 1 millimeter. There you go. Okay. Ready? Up. Yeah. Okay. Well, looks like it's doing well with 1mm. So I'll cut this piece into dimensions and then the two sides, and then we do the other two. So now it should be 55mm and parallel this way. Well, let's see. Okay, this side, and this is something. Okay. 55mm exactly. Okay. Now the other side then. I'm really surprised if there is at least a few hundreds of millimeters deviation here. At least. Yeah. This one is 500ths of a millimeter under, so it is smaller this end than this end. It's not parallel, but very near what I really need. It would have been more accurate if I wouldn't have taken it away from the milling machine in between those cuts, but now I did. Oh, that's funny. Okay. I believe it is there. Yeah. There you go. Let's take 0.5mm first. There's my 0.5mm. It's clean. Yeah. There is my 1mm. But you need to have some cutting oil. This is a high-speed tool after all. Yep. There you go. Okay, I will do this now, build it to dimension, and then we come back. Now I'm doing these features here, two of these on each side of this part, and after that I will be using a 10mm end mill just to put the slot on each side. And after that I will switch to cell mill and mill off. This 5mm part is already taken away, so I only need to take these two away and then do these little angles on the corners here. Well, let's see how that goes. At the moment the hole is 6mm deep and now I have 4 more millimeters to go, and well, let's see. Yeah, so I need to raise the table. I do these 1.5 millimeters at a time. So I have, because my vise is really flimsy, so yeah. And now, since this mill doesn't have, it doesn't have the ability to feed, automatic feed this direction, so this is all manual. There you are, 10 millimeter deep hole, and this milling machine, I'm really satisfied with this one. It's so easy, no chatter, it's built like a tank, and yeah, it shows out. Of course, this wasn't a very demanding milling, but I haven't yet, only when I put my parts in a flimsy way, then it will chatter. But otherwise the milling machine itself doesn't chatter, and that's good. Unlike my lathe, which is generating the chatter all by itself. So, this way, that way. Okay, and I used this one to hammer it in. Again, these surfaces are not at all critical. Okay, we are ready to go another 10 millimeters here. Let's see how well. Oh, my glasses. Always this. Wrong handle. Yeah, as you can see, well, it's not totally accurate. Okay, first 1.5 millimeters. last millimeter. Yeah, and that was real time. Okay. Next, I'll change a shell mill here. This is the shell mill, and this is the collet for that one, and it looks like it's 25 millimeter. It's a little bit loose, but yeah, it should be actually. So now let's take this collet away. Well, it was on carbide end mill this time, because 10 millimeter carbide end mill is the only one I have. And now this is a little bit hard. These smaller collets tend to go there, so therefore and this is something I use. This is a hammer I have made, and it's just a little knock there, and off it goes. It's really, these are really hard to push by hand out sometimes. There you are. And so let's put it there, and well, there you are. I will put the lock here on. Then I can actually do like this. And now this away. Oh. Okay, and now the speed is a little bit too much for this one, but well, actually we have now, it's suitable because I put it in low gear. So first of all, let's center this. Oh, yes, it's on low gear, somewhere in between, like that, and lock that one, and then go here, and then try to touch with this one. And now I need my glasses. It's the sound is, well, this is too slow. I can tell. Let's put a little bit more speed into it. So it was 100, and we need at least 3 times that, so there is the suitable speed if we are using high gear. And this one, you don't change the gear while it's running. It will be a horrible sound, and you will actually eventually destroy your back gear. We need to take away 5 millimeters. So 5 millimeters. Because first 1.5 millimeters. think we could use a little bit faster feed here. So at the moment I have chosen here the low speed area, and so it's 38 millimeters per minute. But let's put a little bit more. So now it's quite a bit more actually. Let's see what happens, because well, what we are not after here is the, well, you will soon see, the surface finish is superb, really, but it's really good. We don't need that kind of surface finish this time. Just take away the material. This is how the burr looks like. Well, on this side we have a lot of that, on that side as well. Here is almost nothing, and same here, almost nothing. And the surface is, well, it's a little bit concave, I believe. It looks like that, but I don't know. It could be also because it contains those, it could be a Fresnel effect. I don't know. But anyway, this looks really nice. And now I just use a file to get rid of these. And then I would like to show you what kind of cuttings this produces. They are there and there. As you can see, they are blue. And what this means, they were hot, and they are really hot, and they fly everywhere. So therefore this thing is really needed. Well, I haven't got a permanent solution for that one yet. Maybe I shouldn't. Just use the pieces of cardboard when I need. This is also a solution. And now I'm going to grind this sharp corner away. Grind, mill. And well, I need to put it in some sort of angle here. And since this angle is not very critical, you can put whatever angle as long as it is nice. So what I found out is that there is a slot inside the vise, and then I use this, put that there, and then lean against the vise slot and push this down. There you are. And when milling the other side, I do exactly the same. And there you are. Yeah. By the way, this piece is something really hard stuff, and I'm always afraid that it breaks down, but it doesn't bend. I believe this is high-speed steel. Something really hard, anyway. So now we should mill it. Next step here will be to drill two 6mm holes here. Okay. This is just to make, because what I'm going to do now, I'm going to drill a hole there. And then I'm doing a big chamfer for that one, so then we can center that one, for using that one in the lathe. So, this is a setup that, it's quite familiar for everybody. Well, and this is the reason why I needed the center hole in here. Now I just turn this, and then I will center it. Center the hole, actually. And after that I will bore it, and after that I will no, I first drill it, then I bore it, and exactly to, well, a hair under 32 millimeters, so that I can press the bearings in there. Yeah. Haha. That drill was horrible. Oh, this is way better, but we need to hammer it in. Yeah, way better. Oh yeah. Well, this didn't cut. It pushed the material. I need to learn how to grind this. This is really horrible. Yeah. So I'm taking 1mm cuts here, actually. And this one benefits from cutting oil. Now I have changed, this is another insert and actually another boring bar. It's anti-K, very stiff. It's slim, but it's for, I don't know what the material is, it's really stiff. And then the insert has a round edge, and with this is a cermet insert, so it's possible to take well, maybe 300ths of a millimeter at one time, that kind of cuts. And of course it's really slow to take that way, so yeah, okay. And when I said that this is 31mm, well, it's quite exactly. Let's see now. Yeah, it feels good. Okay, there you are. Well, and of course this is a mistake. You shouldn't do it like this, but I'll do. Of course you should have a gear on. There you are. Oh yeah. That's ready. If it's too loose, I will glue the bearing instead. So always a backup plan. So my Chinese lathe, that's endless source for inspiration. Well, to put this beautifully. Well, there is always room in improvement in this one. And this latest improvement proved to be probably the best one so far. Well, it made the whole difference on the feel. Because when I do turning with this lathe, it's a lot about feel. And this crunchy hand wheel lost all the feel, but now it's transmitting everything that is happening in the toolbit into my hand, so I can feel it. Doesn't sound like much, but actually it is for a hobbyist like I am, doing everything by hand. And this one I can feel immediately if something is not correct. For example, I can adjust the speed or adjust the feed just by turning, and it's not question about the speed, it's a question about the force. So when you keep constant force with your hand, you get very constant result. Okay, that all said, the next thing to do for that one is to do this motorized feed. It has one for threading, and the speeds are like that. The slowest speed is far too fast for me. You cannot really make a good surface finish with that one. No, you cannot. It's making micro threads actually. Well, even the slowest speed you are making micro threads. And furthermore, if I'm using a DC motor, I can make it a constant force instead of constant speed. It's quite easy to do actually with a DC motor. So let's see how that comes out. But the first thing, you probably noticed there is some room for the dial. The dial, the original one, as you saw, it's a choke, and I need a new one. But since I don't have a dividing head, so I have to wait until the one I ordered comes in, and then I make the dial. And furthermore, I make a gear for that one, for this motorized feed. Well, that's probably a few of the next episodes are dealing about these things. But now, yeah, till the next time, see you!